Welcome back to your favorite intermediate algebra class. We're going to talk about ellipses today. We're going to go ahead and graph and write some equations of ellipses and use an ellipse in a real life situation. So let's take a look here at this ellipse. Okay, this kind of oblong shape here. The definition of an ellipse is a set of all points such that the sum of the distances between that point and two distinct fixed points, which we call the foci, you see the two focus points there, is a constant. Is a constant. So if you're looking here, we have this point P right here, right? So let's say this distance 1, I don't know, let's say it's 6. Let's say this distance 2 is 3. So 6 plus 3 is 9. So it's a fixed constant, right? This 6 plus 3 is 9 here. Well, if we move that, so it's all of these points should add up to 9. So if I go, I don't know, let's say I go to right here, then that distance 1, let's say it's 4. That distance 2 would be 5. 4 plus 5 is 9. So all these points are going to add up to this constant of 9. Okay, so it's the set of all those points such that distance 1 plus distance 2 is a fixed constant. Okay, now let's look at some of these properties that are going to help us to graph this thing. Okay, you could have an ellipse with a horizontal major axis, okay, such as this first one here on the left. Okay, we're going to call the vertices here, they're going to be at the point A0 and negative A0, such that this whole length here is 2A. Okay, that whole length is 2A. So those are our vertices, okay, when our major axis is horizontal. And then up here, we're going to call these our co-vertices right there, okay? So it's a point 0B, 0, negative B, so that this length here is 2B total length, okay? And then we got these foci, okay? And they're on our horizontal axis. Remember our major axis here was horizontal, right? So these foci are on there, okay, and they're at the point we're going to call that C0 and negative C0, such that it satisfies, look down here at the bottom, C squared equals A squared minus B squared. Okay, that can be an equation that you might use if you know your vertex, your vertices A0, negative A0, and your covertices, so you know the B value. Okay, you can find that C by plugging it into C squared equals A squared minus B squared. Okay, that's going to be the location of your focus points. All right. And remember the ellipse, those focus points are important because if you remember, it's the set of all points such that the distance back to your foci is a constant, the sum of those distances. Okay. And that's what creates this ellipse. All right. Now, so let's look over here on the right. Similarly, except when your major axis is vertical, now your equation changes to x squared over b squared plus y squared over a squared, okay? And a is always greater than b. Okay, a is always greater than b. Notice when you had this horizontal major axis, okay, it was x squared over a squared plus y squared over b squared equals 1. That's your standard form of that, okay? So when you have your ellipse with your major axis being vertical, your b squared is on the bottom of the x squared, okay? And notice these are both always equal to 1, okay? So this is the standard form we're going to put it in. And your vertex here is at 0a, 0, negative a. Co-vertices are on that horizontal direction there. And your foci are on that vertical major axis. Okay, so let's look here. We'll revert back to this here, and when we do this problem here, draw the ellipse given by x squared plus 4y squared equals 36. Okay, let's write this down. X squared plus 4y squared equals 36. The first thing you want to do, step one, is you want to put this in standard form. And if you remember, both of those, either when the major axis was horizontal, was either equal to 1, or when your major axis was vertical, is also equal to 1, right? So that's what we got to determine. And remember, A is bigger than B. So let's get this, let's force this to be equal to 1. So let's divide both sides by 36. Okay, so now we got x squared over 36 plus y squared over 9, and that's equal to 1. Okay? Now remember, A is bigger than B, so you're thinking to yourself, well, which one is it? Is it this one with my, and I'll revert back to it here. Is it one with where the horizontal major axis is vertical? I'm sorry, where the major axis is horizontal? Or is it this other one? Remember, A is bigger than B, so you know it's got to be this one. It's got to be that one right there, back right here, because you notice this A squared right there is going to be bigger than your B squared, okay? Your A is 6, your B is 3, okay? So let's write that right below it. So major axis horizontal, x squared over a squared plus y squared over b squared equals 1. So your a squared must be equal to 36. So that means your a is 6 plus minus 6. Your b squared equals 9. So your b is 3. Okay? Let's start drawing this thing. Okay, let's put on our vertices. Remember, the major axis is horizontal, so it's longer the horizontal direction. Right, and let's put on our vertex at a comma 0. So 6 comma 0. Okay, and it goes in the other direction. Negative 6 comma 0 is our other vertex. Okay, so here's our vertex here. There's our other vertex here. Remember, it's at a0, negative a0, so this is at 6 0. The other one's at negative 6 0. Now let's put our co-vertices on here, our co-vertex, which is at 0b. So 0 comma 3. 0, 3. So here's our co-vertex at 0 comma b. 0 comma 3 in this case. And 0 negative b. So 0 comma negative 3. Okay, we can kind of draw this thing now as best we can. Okay, there's our ellipse. Now we are going to find our foci now. So we are supposed to identify the foci. So we say, well, to find our foci, we know c squared equals a squared minus b squared. Right, let me go back to your thing right down here. Let me erase that. Down here at the bottom, you see it there, c squared, the foci of an ellipse lie on the major axis, and our major axis is horizontal. C units from the center. C squared equals a squared minus b squared, okay? C squared equals, remember our a is 6, our b is 3, so we got 36 minus 9, so 25, so c squared equals 25, so our c is 5, okay? Now those foci lie on the major axis, so I know that they're going to be at C0, so 5, 0, and negative 5, 0. Okay? So, do you know what I just realized? Whoops. Daisy on that. My, sorry about that. Arithmetic is faulty. Just kidding. C is the square root of 27. Sorry about that. Okay. So our focus is at the point, one focus is at the point square root of 27, 0. Remember, they lie on the horizontal axis, so they're on this, right? Our major axis horizontal, they're going to be on that line there. Undo that. So square root of 27, 0, negative square root of 27, 0. Of course, this is also the same as 9 times 3, so 3 root 3 comma 0, negative 3 root 3 comma 0. Okay, that's where our foci are at. So square root of 27, you're thinking to yourself, well, where's that at? Well, it's between square root of 25, 5, and square root of 36, 6. So it's between 5 and 6, a little closer to the 5 there. Okay, there's our 1, 3 root 3, comma 0. That's one of our focus points. The other one's right down here. Negative 3 root 3, comma 0, or negative root 27, comma 0. Okay? So it looks like we drew the ellipse. We identify the foci there. Okay, let's do another one. A little bit different here. Draw the ellipse given by 25x squared plus y squared equals 100. So we want to start out putting this thing in standard form if it's not in standard form already. So we got to get this thing equal to 1. So force it by dividing by 100. Okay. So we got x squared over 4 plus y squared over 10 equals 1. Y squared over 100 equals 1 here. Okay, so now we're thinking to ourselves, well, let's see, is it the x squared over a squared? Which one is it? Is it the original with the major axis being horizontal, or is it this other one where my major axis is vertical? And remember, a is bigger than b. So you notice your a squared is going to be bigger than your b squared as well, right? So that 100, is obviously bigger than the 4. So you're looking at this one. Okay, you're looking where the major axis is vertical on your little cheat sheet here, okay? So your major axis is vertical. X squared over b squared plus y squared over a squared equals 1. Okay, let's go back to this problem here. Let me write that down below it here. We'll identify a and b now. So x squared, oops, let me reset here. X squared over b squared plus y squared over a squared. And again, that's because a is bigger than b. So 4 equals my b squared, right? You see that? 4 must be equal to b squared. So b equals 2 when I square root both sides. 100 equals a squared. So square root a is 10. Okay? Remember, our major axis is vertical. Vertical. So now, instead of having it at a comma 0, it's 0 comma a. So 0 comma 10. Right? My long direction is vertical. So my vertex is at 0a now because my major axis is vertical. And 0, negative a. So down there, 0, negative 10. There's my other vertex. Okay, my co-vertices are at B0. So 1, 2, B0. There's one of my co-vertices, co-vertex. B0 in this case, 2, comma 0. And negative 2, comma 0. And I can kind of draw it now. Maybe. Anyways, hopefully yours on your paper is better than that. And then we finally find our foci, and our foci are going to be on that vertical axis. Okay, let's find our foci here. C squared equals a squared minus b squared. C squared equals our a is 10, and our b is 2. So c squared 100 minus 4, 96. So c is the square root of 96, which is, let's see if I got it here anywhere. I don't. That's approximately, let me punch it in. root 96. There we are, 9.798. Approximately 9.798. So it's right there. Again, it's on my vertical axis. There's my other one. 0, my other focus point. 0, comma, negative C, 0, comma, negative 7. 9.798. Okay. All right, let's look at our next one here. Write an equation of the ellipse with the given characteristics and center is 0, 0. Our center is going to be at 0, 0 for this, for the problems that we're working with in this section video today. Okay. So we got a vertex at negative 3, 0, and I always like to make these visual. My vertex is at negative 3, 0. I know the other one's got to be at 1, 2, 3, 0, right? So my major axis is horizontal. Okay, so it's a little elongated horizontally. My co-vertex is at 0, 1. That means my other co-vertex is 0, negative 1. So it looks kind of like this, doesn't it? Okay, and now I can kind of identify. I'm like, oh, if I'm at negative 3, 0, and then the other one's at 3, 0, right? A 0, in other words. Now I know my A. A must be 3. My co-vertex, it was at 0, 1. My co-vertex is 0, 1, so 0B. So B must be 1. So A is 3, B is 1, and now we can write the equation. Okay, if we know if the major axis is horizontal, I'm thinking to myself, x squared over a squared plus y squared over b squared when my major axis is horizontal. So x squared over 3 squared plus y squared over 1 squared is 1. So x squared over 9 plus y squared over 1 equals 1. There it is. Okay, not too bad. Now the second one up here gives you a vertex at 0, 5. Let's draw this one. Vertex at 0, 5. So I know this thing is elongated vertically, right? So my other one's going to be at 0, negative 5. Now I don't know exactly where the co-vertex is, but I do know they give me a focus at 0, negative 2. So my other focus is got to be at 0, 2, right? So vertex, when my major axis is vertical, my vertex will be at 0, comma A. In this case, it's 0, comma 5. So I know my 5 is A. A is 5, right? And then the other thing they give you that 0, negative 2, okay? And so the other one was at 0, 2. My focus was at 0, 2, so 0C in this case. So I know my C must be 2. So my C must be 2, okay? Remember, we need A and B to write this equation for this ellipse, okay? But we only have A and C. So this is what we know so far. We know A, we know C. I say, well, how can I find B? Let's use the old C squared equals A squared minus B squared for an ellipse. And then we can find B because we know C is 2. We know A is 5. And now we can solve that. 4 equals 25 minus b squared, subtract 25, negative 21 equals negative b squared, divide by, move this down a little bit, divide by negative 1, b squared is 21, b squared is 21, square root, b is the square root of 21. So that's between 4 and 5. 4 is the square root of 16, 5 is the square root of 21. Let me go back up here. So it's between 4 and 5. 1, 2, 3, 4, and 5. Those about right there, my co-vertices. Okay, so we can kind of draw this. It's a little more elongated vertically, if you will. Okay, but the important thing is I have my A and my B. You know, my A is 5. Oops. A is 5, my B is the root 21, and I know this thing, the major axis is vertical. Major axis vertical, so I'm going to write x squared over b squared, major axis vertical, plus y squared over a squared equals 1. X squared over square root of 21 squared plus y squared over that 5 squared equals 1. Down a little bit here. X squared over 21 plus y squared over 25 equals 1. There's our equation for that one that has a major axis as vertical. Okay, let's do one more here. The putting surface at a golf course is the shape of an ellipse. It's 20 yards long, 14 yards wide. Okay, so it's in the shape of an ellipse. Let me kind of do it. Okay, 20 yards long. So this whole way across is 20 yards, right? So that means to here, it's got to be 10, right? 10, this way, 10, right? So my vertex is going to be at, since it's longer horizontally than it is vertically, my vertex is at 10, 0. And we know if the major axis is horizontal, that's your A 0. So my A is 10, right? And then we got this thing's 14 yards wide, so it's got to be 7, the other, 7 there. Okay, so my covertex is 0B, so we know that's 0, 7, right? So B equals 7. B equals 7. Write the equation of the putting surface. I say, well, if the major axis is horizontal, it's this one. A is bigger than B, right? So x squared over, again, my A is 10, so 10 squared. My B is 7. So x squared over 100 plus y squared over 49 equals 1. There's the equation of that golf course putting green right there. Okay, find the area of the putting surface. And the area of the putting surface I wrote right there is pi times A times B. So pi times 10 times 7, 70 pi, which is, I better punch this in, approximately 219.911. 219 point. And it looks like we're in, what are we, yards? Square yards, yards squared. Approximately there. Okay, that's the area we got there, how much grass we got on that putting green. All right, thanks for listening. You guys bring your questions to class. Thank you.